Hey, everybody. Welcome back to the show, the podcast where we bravely stare into the abyss of the universe and then immediately make fun of it. I'm your host, Maple, still unpaid by NASA, still over-caffeinated, and still asking the big questions like, why does the universe keep secrets for 13 billion years and then suddenly decide Chile is the place to spill the tea? Seriously, if the cosmos had a group chat, it just left us on read for most of human history. And now, ping! Oh, by the way, here's some ancient microwave gossip from the dawn of time. Good luck, humans.
Well, because that's exactly what just happened. Today, we're cracking open the oldest, coldest case file in existence, the birth of the very first stars. For decades, it's all been theories and models, But now we have a fingerprint. So let's get into it.
So, astrophysicists, bless their extremely patient souls, have just pulled off a major flex. Using ground-based telescopes in Chile, they detected 13-billion-year-old microwave signals from the cosmic dawn. Let that sink in for a second. These signals are older than stars, older than galaxies, older than literally everything you complain about on social media. And here's the wild part. These signals are microwaves, not Wi-Fi, not hot pockets, cosmic microwaves. They've been cruising through the universe for 13 billion years, dodging black holes and minding their own business, only to get picked up by humans on a mountain in Chile going, that's weird. And yeah, big shout out to Chile. Apparently, if you want to talk to the baby universe, you need high altitude, dry air, and zero light pollution. Basically the opposite of my living room.
All right, so to really appreciate what this new clue means, we have to understand the crime scene. We got to go back, way back. We need to open the case file on the universe itself, right from the very beginning.
Okay, so it all kicks off with the Big Bang, right? Everything is just this ridiculously hot, dense soup of stuff. In the first few minutes, you get your basic particles, protons, neutrons, electrons, but it's all a chaotic mess. Then, we wait. For about 380,000 years, the universe finally cools down enough for these particles to pair up and form the first real atoms. And that is a game changer. Suddenly, light can travel freely for the first time, creating this incredible flash across the entire cosmos. We can still see the afterglow of that flash today. We call it the cosmic microwave background. It's basically the universe's baby picture.
But here's the crazy part. After that brilliant first flash, nothing. The lights just went out. For millions of years, the universe was plunged into total darkness. This period is called the Cosmic Dark Ages. Seriously, there was nothing to see. No stars, no galaxies, just a huge, quiet, expanding fog of hydrogen gas. Kind of spooky, right? Of course, this long, dark period wasn't going to last forever. Eventually, the first witnesses appeared on the scene. And these are the ones who would not only break the darkness, but leave behind the very clues we're hunting for today. No, we're not talking about your average, everyday stars here. Oh no, these were the originals, the prototypes. We call them Population 3 stars, and they were absolute monsters. Made of almost pure hydrogen and helium, they grew to be hundreds of times more massive than our sun. And because they were so big, they lived fast and died young. They burned unbelievably hot, just blasting out intense ultraviolet radiation that started zapping the gas all around them. This process, called ionization, is what slowly but surely brought an end to the cosmic dark ages. And this, my friends, is where our mystery gets its smoking gun. Because as these first stars were lighting up the cosmos, they were also leaving behind a unique fingerprint, imprinted right on that hydrogen gas, just waiting for a detective to find it 13 billion years later. That fingerprint is something called the 21-centimeter line. Now, it sounds technical, but just think of every single hydrogen atom in the early universe as a tiny little radio station. It naturally broadcasts a super faint signal at a very specific wavelength, 21 centimeters. So if we can tune into that signal, we can create a map of all that invisible gas and see what it was doing. We can see where it was clumping up, and most importantly, how it was being affected by those very first stars. But just finding this signal isn't enough. The real breakthrough, the aha moment, is detecting its polarization. Think of it this way. The raw signal is like a chaotic crowd, with light waves vibrating in every possible direction. It's a jumbled mess of clues. But when ultraviolet light from the first stars hit that hydrogen gas, it was like a cosmic drill sergeant, forcing those waves to align in one specific direction. This alignment? That's the definitive proof. It's the signature that tells us without a doubt that starlight was interacting with the gas. Quick pause before we rewind the universe another few billion years. If you're enjoying this episode, do the algorithmic gods a favor. Subscribe, leave a review, tell a friend, tell an enemy, tell a theoretical physicist who hasn't slept since grad school. Every subscription helps this podcast expand faster than the early universe, minus the dark energy and existential dread.
Okay, let's hit the fast forward button. A very, very fast forward. Jump ahead 13 billion years, and let's meet the team that finally cracked this case. Their investigation isn't happening in some dusty office, but in one of the highest, driest places on Earth.
These are the DepDivs, the CLASS telescopes, perched high in the Andes Mountains of Chile. CLASS stands for Cosmology Large Angular Surveyor, and their mission? Well, it was a tough one. For years, scientists thought it would be basically impossible to detect this faint, polarized signal from the ground. The noise from Earth, our radios, our satellites, our own galaxy, it's like trying to hear a pin drop in the middle of a rock concert. So how'd they pull it off? It was a three-step master plan. First, location. They chose the Atacama Desert, where the high altitude and dry air mean there's less atmosphere getting in the way. Second, they checked their work. They cross-referenced their findings with data from space telescopes like Planck to make sure they were on the right track. And third, the really genius part, they developed incredibly sophisticated methods to filter out all that noise. They digitally removed the signals from Earth and even from our own galaxy until all that was left was that 1 in a trillion signal from the dawn of time. And this really shows why you need different kinds of detectives on a case this big. On one hand, you have the James Webb Space Telescope. JWST is incredible at getting sharp images of the main suspects, the first galaxies. But then you have projects like CLASS. They act like the forensic team, analyzing the invisible stuff between those galaxies. They tell us how those first stars were changing their entire environment on a massive scale. You need both to get the full story. So, what's the big reveal? What did this 13 billion-year-old clue finally tell us? It's pretty simple, but it changes everything. The first stars began shaping the universe far, far earlier than our models predicted. The lights came on sooner than we thought, which kind of challenges our whole timeline of cosmic evolution. But you know how these big cases go. Finding one major clue doesn't mean the case is closed. In fact, it's just blown the entire investigation wide open. This discovery has raised even more questions about the universe's mysterious beginnings. We still have so much to figure out. When exactly did those first stars ignite? How big were they, really? And what role did the first black holes play in all this? The next generation of cosmic detectives, like the massive Square Kilometer Array Telescope, and maybe even observatories built on the moon, are going to take up this investigation and push it even further. The hunt continues. So what did we learn today? That the universe remembers everything, that microwaves are not just for leftovers, and that humanity's greatest skill is waiting 13 billion years and then saying, okay, now I think we're ready to understand this. Huge cosmic shout out to our producer FireflyHaku, because if you're going to illuminate the cosmic dawn, you might as well have a firefly guiding the way. Tiny light, massive darkness. Perfect metaphor. And to you, dear listeners, thanks for hanging out at the edge of space and time with me. Until next episode, keep looking up, keep asking impossible questions, and remember, the universe is old, mysterious, and still somehow surprised we figured out microwaves. John A. Yadada style. Talk to you across space-time next time.